अच्छा ये वाला. Achha, so we had done that. There's metals on the left side and there's non-metals on the right side over here. These are the ones that like to lose electrons. TK, and these are the ones that like to gain electrons. They all want to complete the outer shells, get into a noble gas configuration. The non-metals will continue to gain electrons until their outer shells are complete, and the metals, on the other hand, will lose their outer shell electrons. Okay, so we did dot and cross diagrams of, for example, if you had a metal and a non-metal like Na and Cl, the Cl will gain electrons from Na, and it will complete its outer shell. It will become a negative ion. One electron would be from Na, and Na will lose the outer electrons, and it will become a positive ion. And the positive ion and the negative ion will have an electrostatic force of attraction, which is known as the ionic bond. Ions, positive ions, negative ions, are attracting each other with an electrostatic force. That's the electrostatic force of attraction, ionic bond. Or if you had other examples, you had we did Mg. So we did Mg and oxygen. Mg lost 2 electrons, the outer shell electrons, and oxygen ended up gaining those 2 electrons. Became -2, Mg became +2. So metal lost electrons, outer shell, non-metal gained electrons. And we discussed when do ionic bonds there are all sorts of ionic compounds. Some of them are very strong, some of them are slightly weaker. NaCl is not that strong. That's your normal table salt. MgO is, on the other hand, very, very strong. I told you that ionic bonds, the strength of the ionic bond depends on 2 things. It depends on the attraction between the 2 ions. The attraction is going to be stronger if you have more charge. If you have a positive 2 charge and a negative 2 charge on the other ion, the force of attraction between them is going to be a lot stronger. So greater charges on the ions, that leads to more attraction, that leads to stronger ionic bonds. Or I told you that smaller ions also, because they're more tightly packed, they're closer to each other. The closer they are, the smaller the ion, the closer they are, the more attraction they're going to have. So there are 2 factors that determine the strength of ionic bonds, which were these 2 factors. We did some examples, and I told you the structure of and properties of ionic compounds. I told you that the structure, and remember, you have to use the exact wording in your past paper questions. The structure is that it's a giant ionic lattice. It's a crystalline lattice. It's a regular arrangement of oppositely charged ions. You got a sodium positive ion that will get attracted to a Cl negative ion. It will get attracted to a sodium positive ion, which will again get attracted to a Cl negative ion, and so on. It's just a giant structure, an endless arrangement of positive and negative ions. They're all sticking to each other. They're all attracting each other. The properties were that they usually have high melting points. The ones that have very strong attractive forces between positive and negative ions, they've got very strong, they've got very high melting points. They're relatively strong. Marble, concrete, these are all ionic compounds. But they're also brittle. Okay? This is one thing that we did. And the reason why they were brittle was that the structure is very sensitive to the arrangement. Every time there's a positive ion right next to it, there should be a negative ion. Because positive ions attract negative ions. If there's a negative ion right next to it, there should be a positive ion. So the structure is very sensitive to the arrangement, because if you change the arrangement a little bit, like if you apply a force, like if you have a marble tile, although it's a strong tile, but if you apply a force, or if you apply a large amount of force, and the structure slides a little bit, the ions slightly slip, what will happen is that the 2 negative ions will become right next to each other, and that would lead to a force of repulsion. The 2 positive ions will become next to each other, and that would lead to a force of repulsion. So the point is that this structure, although it's very strong, but the arrangement should not change, not even a tiny bit, because if it changes a tiny bit, the force of attraction that exists between negative and positive ions, that will instead turn into a force of repulsion. Because if the arrangement changes just a tiny bit, the ions, instead of attracting each other, they would start repelling each other, which is why it's a brittle. Like if you hammer a tile, the whole tile breaks. It just breaks into pieces. So the arrangement, because all the arrangement will change. If one ion slips forward, all the ions would slip forward, and the force of attraction will change into a force of repulsion. Okay? Is this point clear? The brittle wala, is that clear?
Yes, sir.
Yes, sir.
I said number 3. Tell me another property. What's the other property of ionic compounds?
We conduct electricity.
So number 3 is that they all conduct electricity in what state?
Liquid.
Okay, in molten, which is liquid state. Do you remember molten state is liquid state? And aqueous state. So they conduct electricity in molten and aqueous state. Can anyone tell me what is electricity? Like when I say current is flowing through a wire, what does that mean? Anyone else? How do you define, in simple words, how do you define electricity? Anyone? Abu Bakr, Zainab, Shoaib, Urwa. Acha Zainab. किसी और को नहीं आता? What? I mean, just.
Sir, is there a
yes.
difference between aqueous and molten?
I'll explain the difference between aqueous and molten. Okay, there is a difference, and I'll explain that. Like the first thing, what is electricity? Simplest words, what does that mean? So I'll just tell you. Zainab, have you typed something or not? I said so. Electricity, in simple words, is the movement of charged particles. Just a second. But it's the movement of charged particles, and any charged particles. The charged particles. How many types of charged particles do you have? You've got electrons. So example is that electrons. Remember, electrons can be lost. They can move around, right? An atom can. So, but remember, the protons never actually move. Like if you look at the dot and cross diagram, right? If you look over here, as the reason I won't count protons in electricity is that protons usually they're just stuck in the nucleus, right? They don't move. It's the electrons that can sort of jump around and they can move from one atom to the other atom. So electrons are capable of moving. Not really protons, although protons are charged particles. That's not. Zainab, is that clear? So protons are kind of stationary. They never actually move. So it's the movement of electrons or ions. Remember, there's another type of charged particles, which is ions. If these ions over here in the lattice over here, if they start moving around, that is electricity. So when you see current flowing through a circuit, it's basically charged particles that are moving around. So they've got to move. It's a movement of charged particles. Now look at ionic compounds. Now ionic compound have ions. They've got positive ions and they've got negative ions. So ionic compounds don't conduct in solid state. And the reason they don't conduct in solid state is that the ions don't move in solid state, as there are no free moving ions. So your ionic lattice would be, I mean, like NaCl. If you look at NaCl in solid state, the positive and negative ions will not. So let's say you've got positive and negative ions. Let me draw a small lattice. So in solid state, the positive and negative ions will not do anything. They won't be able to move or leave their place, because they're all attracted to each other very strongly. So one of them is going to be positive. You'll have a negative ion, positive, negative, attracted to positive, attracted to negative, attracted to positive ion, then negative ion. So there are no free moving ions. Ions are strongly held together. They strongly attract each other. And they can't leave their place. Like, it would be very hard for the negative ion over here to sort of move around, because the positive ions are attracting it. So positive ions from all sides are keeping it in its place. So no electricity in solid state. What happens in liquid state, liquid or molten state? The first thing is, what's a liquid or molten state? Now in liquid and molten state, the ions, remember, if I want to melt an ionic compound like salt, I would have to take it to a very high temperature. A large amount of energy would be needed for this. So in molten state, what happens is, so in molten state, what happens is that the ions have a lot of energy, and the ions can slip around. So they can move around. This negatively charged ion can sort of slip around, and it can move around because it's got a lot of energy. So all these ions will be able to, liquid state where the ions would be able to slip, and they can sort of move around to other places. So the ions are energetic, and what they can do is they can overcome. So they can overcome the strong attractive forces. And can move. So that's why they're able to conduct electricity. The charged particles would be able to move around. Okay, so इसके ऊपर arrows भी बना देते हैं, so I can show you the negative ions, the positive ions. They're all slip and slide. Okay, but you have to, I mean, this only happens at very high temperatures. To melt an ionic compound, you would need large amounts of energy, right? Okay, is that clear? Shoaib, Urwa, Zainab, is this clear? I said, then you've got another one, which is aqueous state, right? So remember, okay, so there's another state, which is the aqueous state. Now, aqueous state is different from a liquid state. Aqueous state, you don't need a lot of a very high temperature. So in aqueous state, they also have free moving ions. So you've got free moving ions which are able to conduct electricity. So I'm going to take the same ionic compound, and let's add a few more. So make the lattice bigger. So let's say this is NaCl. This is your normal table salt. So aqua state is dissolved. It means dissolved in water. Okay? Aqua literally means water. So it means dissolved in water. So what happens? You take the white crystal of NaCl. Okay? Let's imagine this is the white tiny NaCl crystal, right? And you start the first thing when you put it in water, and let's make this slightly smaller. So when you put this crystal in water, and here's this big beaker that contains water, the first thing that you do when you try to dissolve it, you remember water is H2O. So what you do is you stir it vigorously. So you take this and you stir it vigorously. When you stir it, what's going to happen is that the ions will get scattered. Okay, so this is what will happen. I'm vigorously stirring it. Okay, remember, I'm applying with a spoon, I'm applying a large amount of force. So this negative ion, it breaks off the lattice, although it was attracted to it, but I'm stirring it so vigorously, the ions sort of get scattered, right? And slowly the whole salt, every single ion starts to break off, right? Remember, imagine I'm stirring it vigorously with a spoon. So the whole lattice is kind of breaking down into tiny pieces, and the ions are getting scattered. This is known as the lattice getting dissociated, which means that the ions are now still there, but they are now scattered in solution. So one by one, due to my vigorous stirring, let's just scatter them all very quickly. Just a second. I said, due to my vigorous stirring, the ions are all now scattered in water. Okay? Is this clear to everyone what happens when you dissolve it? Right?
Sure.
Okay, so that's why your white salt crystal disappears in water when you stir it vigorously. So solid ionic lattice dissociates into ions. I mean, it's just a fancy word of saying that the ions get scattered in water. Solid ionic compound, ionic lattice, dissociates into ions in aqueous state. Now, some dissociate, some don't actually. Not all ionic compounds, they dissociate, which means that the ions don't get scattered. Like if I try to dissolve marble, like marble is a similar ionic compound. Will marble dissociate? Does marble dissolve? What do you think? If you put marble piece into water, it won't, right?
Yes, sir, it won't.
It won't. So the reason for that is that the ions are so strongly held together is because the ions are so powerfully or strongly attracted to each other. Okay, my vigorous stirring will not pull this ion off and it won't be able to dissociate, right? So the amount of force needed to dissociate it is larger. Remember, marble is stronger. The stronger the ionic lattice, the harder it is for it to dissociate. NaCl was very weak. The ions would get scattered, right? So it all depends on the strength of attraction between the ions. So some ionic compounds which are weak, especially the ones which are weak, वो बड़े आराम से dissolve हो जाते हैं. I mean, I just stir them with the spoon and the whole ions, they just fall apart, right? But the ones that are strong, concrete, marble, etc., they don't. Their ions are very strongly held together. But anyways, this is what happens. So why don't the ions in water get back together again and form the crystal back again? Why doesn't it happen? Okay, NaCl dissolve kiya hoga na? You must have dissolved salt in water, right? Once it gets dissolved, it just remains dissolved forever. Why don't they just get attracted to each other and form the crystal back again? Why don't the positive and negative ions, like if I stop stirring it, why don't they just start joining up and start forming the white crystal back again? Why doesn't that happen? Okay, the negative ion will attract the positive ion. वो तो मैं stir कर रहा था ना, I was stirring it vigorously, which is why the ions were sort of getting scattered, right? But once I stop stirring, they just remain scattered. Why is that? ठीक है, एक second, let me just check. Then the question is, like I vigorously stirred this, right? And the ions got scattered. So, I mean, that's how NaCl dissolves. That's how salt dissolves in water, right? But the question is, if I stop stirring, why don't they just get back together again? Like the positive gets attracted to the negative ion attracts the positive ion. Why don't they start forming the crystal back again? Why don't you get the white crystal back again?
The water is stopping.
Okay, so the water is stopping. There's a lot of water in between, which is stopping them. Remember, there are billions of tiny water molecules that would be coming in the way. Lots of them. That's so, which is why it would be very hard for the ions, once they get scattered, it would be very hard for them to actually join back again. Too many water molecules in the way. Exactly, it's basically water, right? Because if you have like this, there's a negative ion, there's a positive ion, there are billions of water molecules that are in the way. Actual solution, I just drew 5 of them, but there would be most likely billions of water molecules that would be in the way. So it would be very hard for a negative ion on one side and a positive ion on the other side. And there are so many water molecules in the way that that it would be impossible for them to join back and form the crystal back again, right? So once they're dissolved, they usually remain dissolved, unless you do one thing. And what is that one thing? That's known as crystallization. We did discuss crystallization in earlier topics. So there's one thing that you can do to form the crystal back again, and that is you get rid of the water. If I start removing the water molecules in between, there's a point called crystallization point, or known as saturation point. That is the point that if you remove enough water molecules from between them, that there would come a point where the crystals would start forming back again. There would be no hindrance. The positive will get attracted to the negative will get attracted to the positive, and that's how crystals are going to be eventually formed. Is that clear?
Yeah.
इधर वैसे pictures भी दिखा दें, crystallization of so maybe, and you can form really beautiful crystals out of it. So I guess this is, if you can see this image over here. So that's how crystals are formed. That there are lots of scattered ions. This is copper sulfate. That's a blue colored salt. So what you do is you remove a lot of the water molecules. Once you get rid of a lot of the water molecules, and the thing is, you don't want the water molecules to vanish all of a sudden, because if you remove them all of a sudden, like you heat it so strongly that all the water molecules, they evaporate, they just leave the container, right, due to evaporation, then there won't be enough time for the positive and negative ions to get back together to form this nicely structured lattice. You would have to give it time. So you do this very, very slowly. You don't get rid of the water molecules all of a sudden. So crystallization requires some time, because this negative ion would take some time to find its spot. It will then, I mean, it's randomly moving around, right, in the water, right? And eventually it comes over here and it finds that there's 2 positive ions, it will get attracted to it. So crystallization requires some time. You have to keep it there for a certain amount of time. Only then will crystals be formed. So that's how crystallization happens. And you can form crystals of normal table salt as well. But for that, you would have to get rid of water molecules. But anyways, coming back to the main point, which is that ionic compounds, they dissociate. That's aqueous state. Okay, so imagine this is aqueous state. So in aqueous state, no one is keeping the ions I said no one is keeping the ions together. Aqua state, there are lots of water molecules, so the ions are just freely randomly moving around, right? So this ion, no one is stopping it because it's not getting attracted to the other ions. So in aqua state, you've got free moving ions. Is that clear? And there's a difference between aqua state and liquid state. You can just hold on 1 second. Sorry. So you've got so remember molten state, there is no water, right? There's just you just take it to a very high temperature and the particles become so energetic that they start it's got so much energy that it starts moving around and it becomes liquid, right? So the ions kind of start moving around. And movement of charged particles is electricity. So in molten state, in aqua state, you're going to get electricity. In solid state, the ions are so strongly held together that there would be no electricity. Okay. I said the last property of ionic compounds is the fourth one, which we've already kind of discussed, that most ionic compounds, they dissolve in water. All of them, they dissolve, but the solubility is different to a different extent. So the fourth point is that ionic compounds, they dissolve in water. But their solubility varies. Some are more soluble. So the solubility varies a lot. And I told you why it varies a lot. Zyada force of attraction hogi, if it's a larger force of attraction, it would be very hard to dissolve. If there's a weak force of attraction between the ions, then they would scatter or dissociate very, very easily. So the solubility varies from ionic compound to ionic compound. Marble doesn't really dissolve a lot, but marble does dissolve, but very little. Table salt dissolves a lot or very easily dissolves. Okay. So that kind of sums up the properties of ionic lattices. Okay. Sara, clear? Is this clear?
Yes.
Yes, sir.
But remember past papers, Meki, you have to get the wording right. You have to, everything has to be very precise, very specific. They're going to ask you why do they conduct electricity in aqueous or molten state? Because they've got free moving ions. Okay, that's the answer. Why do they conduct electricity? Why don't they conduct electricity in solid state? Because the ions are strongly held together and there are no free moving ions in the lattice. Okay, why do they have high melting point? Because the positive and negative ions, they attract each other very strongly in the giant ionic lattice. So you have to have very specific, precise answers, which I've already written over here. So now the only thing we're going to do is we're going to do more examples of dot and cross diagrams. Okay, so more examples of dot and cross diagrams, specifically the ones more examples of dot and cross diagrams, specifically which ones? Where there's an unequal gain and loss of electrons. So as an example, I've got sodium, which is my metal 11. So the electronic configuration of sodium is 281, right? And there's a non-metal, which is, let's say, oxygen, which is 8. That means it's 2 and 6. So I'm going to draw the sodium atom. I'm going to draw the oxygen atom. Sodium would be 2, 8, and 1. So 2 electrons. Then I've got 8 electrons, and then I've got 1 electron. And similarly, I've got oxygen. Here, that's 1. That is the oxygen atom. So sodium will be 2 electrons, 8. As a first thing, it's a metal. How many electrons will it lose? Sodium.
One, sir.
You can remember the metal will lose all its outer shell electrons. So it's going to lose exactly 1 electron. And on the other hand, I've got oxygen over here. On the other hand, I've got oxygen over here. And oxygen has, it's 2 and 6, right? So how many electrons does oxygen need to complete its outer shell?
2, sir.
It wants to gain 2 electrons. So oxygen will continue to gain electrons until its outer shell is complete. And sodium will lose all its outer shell electrons. Now there's a problem. Sodium is only losing 1 electron. So how does oxygen get another electron? I say anyone, how does oxygen get the other electron?
By sodium. Sodium.
It gets it from sodium, but sodium is losing just 1 electron. So where does it get the other electron? It wants to gain 2 electrons.
Uses 2 sodium.
Yeah, so the point is that there's going to be 2 sodiums. Remember that there's going to be 2 sodiums. Just 1 second. So the point is that there's going to be 2 sodiums. Because 1 sodium only loses 1 electron, but oxygen needs 2 of them, right? So there's going to be 2 sodiums. And this is what's going to happen. There's going to be another sodium. And let's keep it here. So there's going to be 2 sodiums. Oxygen is going to gain 1 electron from this sodium. And oxygen is going to get the other electron from this other sodium. So in total, it's going to gain 2 electrons. So 1 from here and 1 from this side. So basically at the end of the day, not the second shell, remember this. Sodium will only lose electrons from the outer shell, not these electrons. Nothing will happen to them. Sodium इनको बड़ा attract करता है. It doesn't want to lose those. वो जो बाहर वाला है ना, that's the 1 electron that it's going to lose. So if oxygen wants to gain 2 electrons, it has to find another sodium. So the end result is that oxygen gets its 2 electrons, and your final dot and cross diagram would look like this: that both sodiums will have a +1 charge, right? And oxygen will have a -2 charge. So the end result is that oxygen gets a -2 charge, and both sodiums, they've lost their outer shell electrons. So I'm going to remove them, and they're going to get a +1 charge. This one as well. So +1. And there's going to be a mutual force of attraction that's going to exist between these ions. The positive ions will be getting attracted to the negative ion. That's how. And this other sodium ion will probably be on the other side. That's how the dot and cross diagram would look like. So, but is this point clear so far? I'll show you an easier way of doing this, but is this point clear? This one. Okay, when you have
Yes, sir.
so when you have unequal electron sharing, the problem would be that एक atom की quantity you would have to increase that quantity because oxygen will not be able to gain 2 electrons from just one sodium. It needs another sodium. But there's an easy way of doing this as well, and that easy way is that let's say I do the same example. The easy way is that's known as the crisscross method. Whenever you तो ये बस easy way एक example करते हैं. Whenever you face this difficulty, ठीक है? Because remember, doing the whole thing that is kind of it kind of gets confusing. You need a shortcut for this. ठीक है? So the hack is, let's start from scratch again. Now what I'm going to do is, I wouldn't go into the details. I'm just going to deal with the hack, which is that put this electron back. We're back at the starting point. This is what sodium and oxygen looks like. So the simple hack is, how many electrons will sodium lose? 1. Right? It loses 1 electron. Fine. Make it lose that 1 electron. So if it loses that 1 electron, what charge will it have? It will have a charge of +1, right? Then move to oxygen then. Exactly, okay? Like this is, because remember, sodium will only lose the 1 electron in the outer shell. It won't lose any more than that. So if it loses 1, that's it. So if it wants another electron, if it wants to gain 2 electrons, then the second has to come from some other atom, not the same one. I'm just telling you the hack now, okay? You don't have to go into, like when you're doing dot and cross diagrams, you don't have to go into all the details. Just understand what's happening, but this is all you have to do. Sodium wants to lose electrons, make it lose 1 electron. What charge will it have? It will have a charge of +1. Oxygen over here, how many electrons does it need? It needs 2 electrons. Give it 2 electrons. We don't care where they come from. If it wants to gain 2 electrons, fine, give it 2 electrons. What charge will it have? It will have a charge of -2, right? So it's going to have a charge of -2. Okay, that's the first step. We don't care where the electrons are going, where the electrons are coming from. Sodium wanted to lose 1 electron. We did that. The other one wanted to gain 2 electrons. We gave it 2 electrons. The final step is the hack. Okay, there's a 2 written over here. If there's a 2, forget the charge, whether it's minus or plus. If there's a 2 written over here, all you have to do is, there's a 2 written over here. Go to the other end, multiply it by 2. And there's a 1 written over here. Forget the charge, +1 or -1, we don't care. There's a 1 written over here. Go to this one, multiply this by 1. So that means there's going to be 2 sodiums and there's going to be 1 oxygen, which is exactly what we came up with. That there were going to be 2 sodium ions and there's going to be 1 oxygen ion. So instead of drawing the 2 sodium ions twice, you could just do this, multiply it by 2. 2 sodium ions, 1 oxygen ion. That's it. Is this clear? Again, this is known as the crisscross method. Okay, there's a charge of -2, so multiply the other one by 2. Forget minus or plus, just multiply the other one by 2. There's a charge of +1 over here, so multiply the other one by 1. So there's going to be 1 oxygen and there would be 2 sodium ions, which is exactly what we got. There's going to be 2 sodium ions and there's going to be 1 oxygen ion. Okay? So we'll do more examples in the next class then. Okay, but is this point clear? This one, you clear it?
Sorry, can you repeat kind of a recap it again?
I'll do another example. Let's say I've got just a second. I'll just do another example. Let's say I've got Mg and F. Okay, there's a dot and cross diagram that's going to we're going to make Mg and F. Okay, so let's do another one. Mg is the metal and F is the non-metal. One is group 2, the other one is group 7. So the electronic configuration of Mg is 12 electrons, so that's 2, 8, and 2. Fluorine is 9. So, I mean, this is 12 and this is 9. 9 is going to be 2 and 7, right? So let's draw the circles. So this one is Mg. So it's 2, 8, and 2. First thing, how many electrons will Mg lose? Okay, how many electrons will Mg lose?
1.
Remember, a metal would lose all its outer shell electrons. Like this.
2.
Okay, remember this, a metal would lose all, I mean, it's going to lose the whole outer shell electrons, all of them, right? It doesn't attract the outer electrons very strongly. So it's going to lose all of them. So it's going to lose how many? 2 electrons, right? Then you've got fluorine on the other hand. Fluorine is 2 and 7. So I've got fluorine 2 and 7. As a fluorine ka batao, how many electrons does fluorine need in its outer shells to complete the outer shell?
1.
It needs, so remember, the non-metal will gain electrons until the outer shell is complete. वो करता रहेगा gain जब तक उसके पास जगह नहीं होगी, ठीक है? Once it's full, then it will stop gaining. So the non-metal will continue to gain. In this case, it will only gain 1 electron. Now we have a problem at our hands. Mg wants to lose electrons. This one only wants to gain 1 electron. So ab batao, okay, this 1 electron over here goes and fluorine gains it. Now tell me, what will happen to the other electron? Like fluorine cannot gain it because it's full already, right? But Mg wants to lose 2 electrons. So how many fluorines do I need? Sorry. इसको वापस करें ये. How many fluorines do I need? In this case, I would need 2 fluorines because this is going to lose 2 electrons. A single fluorine atom can only gain 1 electron. So the other electron that the Mg is losing has to go somewhere. And that one will go to this other fluorine. Okay, so 1 electron goes over here. And the other electron goes to this other fluorine. So in that way, the outer shell of Mg is lost. And fluorine is able to complete its outer shell. Fluorine will get a charge of -1, both of them. Okay, so the electron came from, 1 electron went over here. The other one went over here. Okay, and it was able to, what charges is like the thing you got -1. ठीक है, because it's gained electrons. This one also it's got एक से मैं let me and this Mg will have a charge of +2. अच्छा, just a second, क्या था? अच्छा, मैं repeat कर देता हूँ, but is this clear to everyone else?
Yes, sir.
ठीक है, I'm just going to repeat for Zainab that इसको उठा के एक से वापस लेके जाएं. Hold on a second. Yep. This, and then we had Zainab, this is what's happening, that that the metal loses electrons, the non-metal gains electrons. So this is Mg's electronic configuration, 2, 8, and 2, right? Mg had 2 electrons in its outer shell. It's going to lose both of those 2 electrons, right? Fluorine, on the other hand, had 7 electrons in its outer shell, so it will only gain 1. So if Mg is losing 2 electrons, so it gives 1 electron to fluorine. So this fluorine is done. Its outer shell is completed. It becomes -1. So how does Mg lose the second electron? So there's going to be another fluorine. Mg gives it to another fluorine. So there's going to be 2 fluorines. So this other fluorine gains another electron and its outer shell is complete. So in this case, you'll have 1 Mg and 2 fluorines. Is that clear?
Yes, sir.
Okay. But now I'm going to come to the shortcut. I mean, this takes a long time. Like there's going to be 1 Mg and 2 fluorines. The shortcut is, or the simple hack is, this is all you have to do. Okay, let me draw this over here again, which is the crisscross method. Okay. So Mg and fluorine. इसका electron वापस कर देते हैं. अच्छा, the shortcut is draw Mg and fluorine. Let's go. So let's go back, electron back, TK, and there's another electron. So that's Mg and that's fluorine. So the shortcut I told you was that forget the whole electron transfer, everything. TK, all you have to draw is Mg wants to lose 2 electrons. Make it lose 2 electrons. Gone. And if it loses 2 electrons, it will have a charge of +2. Forget where they went. We don't care where they went. Mg wanted to lose the 2 outer shell electrons. A metal would always lose the outer shell electrons. So they're lost. They're gone. Okay. Fluorine wants to gain 1 electron. Give that 1 electron to fluorine. Where it came from, we don't care. It's gained that 1 electron, right? And it will have a charge of -1, right? So that's the first step. If it wants to gain 2 electrons, give it 2 electrons. If it wants to gain 3 electrons, give it 3 electrons. Fluorine over here wants to gain 1 electron, just give it 1 electron. So that's the first step. And the second step is crisscross, which is if you see +2 over here, forget the plus, go and multiply the other one by 2. And if you see a -1 over here, forget the minus, just go and multiply the other one by 1. What that basically means is that the dot and cross diagram, there's going to be 1 Mg and there's going to be 2 fluorines, which is exactly what we did over here. There's going to be 1 Mg, which is +2, and there would be 2 fluorines, which will have a charge of -1. And that's your dot and cross diagram. Okay, so you don't have to worry about who's gaining electrons, who's losing electrons, how many electrons are lost, how many electrons are gained. All you have to do is, if this wants to lose 2 electrons, make it lose 2 electrons, put a charge on top of it. If the non-metal wants to gain 1 electron, give it 1 electron, put a charge of -1 over here. And then just do crisscross. 1 over here, multiply the other one by 1. 2 over here, multiply the other one by 2. That's it. Okay, is this clear?
Yes, sir.
So we'll do some more examples in the next class as well. slightly more difficult examples. But that's going to be our dot and cross diagram for magnesium and fluorine bonding to each other ionically. One metal, the other one is a non-metal. Okay. So if question is Zainab, is this all clear? Ayan, Harish, Orwa, is this clear?
Yes, sir.
Just remember, we'll do more questions tomorrow as well. Okay, then take care, everyone. Allah Hafiz.